Welcome everybody. Today we are going to go through setting up your own Helix Core Perforce server in AWS using our enhanced Studio pack, which makes it super quick and easy to deploy a production-ready server. I'm Jace Lindgren, a solutions engineer at Perforce and an AWS certified cloud practitioner. The structure of this video has three main sections. There's pre-deployment steps that we need to do to get ready, the actual deployment step of filling out the template, and then we're going to cover more advanced things that you can do after it's deployed to make sure it's set up and that it's sustainable over time. The first section is pre-deployment, which involves creating an AWS account, getting the link to the ESP template, choosing an AWS region for your server, and creating an SSH Key Pair. If you already know how to do all of those, feel free to skip ahead. There are chapter markers throughout this video to make it really easy to skip to what you need. Then we're going to move on to the deployment section itself. This is where we're going to go through the enhanced Studio Pack CloudFormation template, where we'll configure our network and security, choosing our instance type and our disk sizes for the server, as well as optionally deploying Swarm and/or Hansoft. And then finally, we'll get to post-deployment. First, we're just going to connect to the server using P4V and P4Admin, understand how to get your credentials for that. We're also going to talk about connecting to the server terminal itself for more advanced admin tasks. And we're going to talk about adjusting the security groups in AWS so that other users besides yourself can actually connect to your server, which is most likely what you'll want. Then we'll get into some more advanced things, which is configuring the automatic snapshots to adjust how many of those there are. We're also going to look at how you can increase your disk sizes later on and change your instance type later on, whether you need to make that bigger or smaller based on how you're using your server. So again, feel free to skip to whatever section you need, or just keep going and we'll go through all of these steps to get you the basic knowledge you need to be able to set up and also run a server on AWS. Before we get started with the setup, there are four very important things we need to do first. The first one is on AWS, we need to create an account. So go to aws.amazon.com and click Create an AWS account up here if you don't already have one. Otherwise, you can just log into your account and then we will go from here. The next thing you're going to need is the link to the CloudFormation template from Perforce. There are several different pages on Perforce where you can do that, but what we're going to do is go to Products here and then Helix Core. And then on the Helix Core page under Helix Core Overview, you'll see there's one called Cloud Deployments here. If we click on this, we'll see this form over on the right side. That's what you need to fill out in order to get that link. When you get to this last question here, where will you deploy? You want to choose the cloud provider that you want to use. So in this case, we're going to choose AWS, fill this out, and submit. After you submit, you'll get an email with a link to the CloudFormation template in it. The next thing we need to do is choose what region we're going to use. Up in the upper right-hand section of the console here, you can see a drop-down of all the different regions where there are AWS data centers, and you're going to want to pick one that's the closest to where most of your users will be connecting. In this case, I'm going to choose Central Canada just because I don't have anything else in that region right now, so it will look cleaner like yours will when you're first starting out. The last thing we need to do before we get started is to create an SSH Key Pair and import it into AWS. The place where we're going to do that is under EC2. You'll see mine shows up under Recently Visited, but if yours doesn't, you can just go to the top here and type EC2 and select that for virtual servers in the cloud. Then on this left-hand panel, we want to scroll down under Network and Security to Key Pairs. It is worth noting that key pairs uploaded are region specific. So if you do this in a different region from the one you try to create your ESP in later, you will not see your key pair. So you'll have to go back to that region and add it there. So if you click Create Key Pair up here, this will automatically do it on AWS's side, and then you can download the private key half of that. While it is possible to create your public key from that so you can give it to other places, I find it simpler just to create the public and private key pair myself and then just import that through Actions, Import Key Pair up here. I'm on Windows, and some Windows guides will have you do this through PuTTY, which is historically the Windows SSH client, but modern versions of PowerShell for the last several years have SSH functionality built into them, and they work the same as Linux and Mac. So by doing it this way, this same command will work whether you're on Linux, Mac, or Windows. The command is SSH-keygen and then -t for type, and we're going to choose RSA. It's an older type of encryption, but it's used by all SSH clients, so that will work on the most machines. And then -b, we'll choose 4096, which is larger than the default and larger than the minimum that AWS requires to make our key a little bit harder to crack as computers get stronger in the future. And then if you want to, you can specify -f and put a file name here. This will be a file path of where it's going to put both the private and public keys. I'm going to hit enter. It's generating my key pair. I can enter a passphrase if I want to password protect this further. I'm just going to leave it blank. And then I'm going to hit enter again. And I can see now that my identification has been saved where I told it to. And since I'm in that directory, if I type ls to list the directory, I'll see I have my new key, which is my private key. This should not be shared with anybody, and I need to be sure that I keep this somewhere safe. And then I have my new key.pub. That is the public half of the key, and that's the one I'm going to put on AWS and that I can freely give out to other people who want to grant me SSH access into their machines. So now back in AWS, I'm going to go up to Actions, Import Key Pair, give it a name. I like giving it the name that matches the file so that I know when I see it in AWS which one it is for me, but you can do it however you want. I'll hit browse, go to my ESP demo folder where I put that, and my new key.pub, hit open. You will see it fills in the value into here, and then I'm going to hit import key pair. So you can see now AWS has that public key. All right, that's it for the setup. Now let's actually click on that link that you got in the email and fill out the template. I just clicked on the link in my email and it brought me to this CloudFormation Quick Create Stack page. Now, one thing to note is that that link is tied to a particular region. So in this case, you can see it's changed me to North Virginia, which is US East 1. That's not the one I want, and I stress this because there's so many times I've done this and been confused why I couldn't find my key pair. So I'm going to change to Canada Central, which is the one I chose there. And here we are. All right, first thing we're going to do is give our stack a name. This is just for your own benefit of being able to find it in your CloudFormations. Next, under permitted IP range, we need to tell it what IP address is allowed to connect to this server. This includes both connecting to Helix Core and also using SSH to connect into the actual terminal. So I highly recommend not opening this up to the world and instead restricting this just to your own public IP address. So to find that, you need to go to something like whatismyip.com, click on that, and you will see your public IP displayed there. I'm going to copy that to my clipboard, come back in here. We need to keep the /32 part, but we'll put our address there. This CIDR block, leave that as it is unless you have a specific reason for changing it. And now under SSH Key Pair, this is where we will see that new key that we just imported. Under P4D instance type, so this is going to choose the AWS instance that will actually be running your server. So this determines how much RAM, how much CPU, things like that. The two big ones we're going to want to pay attention to are CPU and RAM, because those will most directly impact the performance of your server. If you want a nice comparison of all of these different types of servers, we have a link to it in the description here. It's this instances.vantage.sh. If I enter that in my browser here, you can see that this is a site that collects all of the data about the different types of servers in AWS and allows you to do things like filter them by their name, by how much memory they have, how many CPUs they have. This makes it really convenient, and you can see over on the right, it will actually show you what those costs are, and you can change that up here between monthly, annually, hourly, daily, weekly, and you can also look at comparing that to reserved costs on AWS. So this is a really convenient resource. But the really cool thing about the cloud is that we can change this later on. If we realize, oh gosh, I picked something really big and it's expensive and I'm not taking advantage of it, I can do that. Or I can start with something small and then just increase it later on as I grow. So for this, I'm going to start very small, and I'm just going to go with a T3 micro right here. Next, we have to choose whether our server is going to be case sensitive or insensitive. If you are only working with Windows clients, so your users, all of your users are just using Windows, then insensitive makes sense because Windows is case insensitive. But if you're using any Linux servers, generally we would recommend sensitive unless you know for sure that insensitive is your preference. And we have some links to documentation about that here. I'm going to leave this on sensitive for now. Snapshot ID, this is if we were restoring from a backup. We are not doing that. We're making a new server, so we're going to leave that blank. And now we have 3 different volume sizes. So we have our depot volume, which is where the actual files themselves will be stored. We have our log volume, which is where our running logs from the server, as well as the active journal files will be stored. And then we have our metadata volume size, which is where the actual database of all of our files, who submitted them, when, permissions, things like that will be stored. Generally, your log and your metadata will be significantly smaller than your actual depot volume as it grows. 100 gigabytes is the minimum for a depot volume on AWS. One way to think about this is to think about how large your project is right now, or if you have a sense of how large it's going to be very soon, set this to maybe 2 to 3 times that amount so that you have some extra room. But keep in mind that you can always increase this later on. And this can actually be increased even without shutting down your server. You can just increase it while your server is still running, which is very cool. However, you can't decrease it. So you can start a little bit on the small side if you want, but just be sure you're keeping an eye on that and increasing it if you start running out of room. For the log volume and metadata volume, I usually start these at about 1/10 of what the depot volume is. But again, you just want to keep an eye on these and increase their size as needed. That's it for the Helix Core section of this. What happens next is Swarm configuration. So this is for setting up another server on AWS for Swarm, which is our code review tool. If you leave this set to true, then it will create a Swarm server that's linked to your Helix Core server, and you can use it for reviewing each other's code, kind of like a pull request. So if that's something you're interested in, you can leave that on true there. I'm going to set this also to a T3 small because I don't need a real beefy machine for this. This one I could probably set even smaller because this is not storing the actual files itself. It's just going to be storing data about my reviews. So I'll set that one a little bit smaller here. Again, that's up to you. You'll just need to keep an eye on it. And then the last section is for Hansoft configuration. Hansoft is our agile planning tool. So if you'd like to set up a server for that, you can leave it to true. Otherwise, you can set it to false. I'm going to set it to false right now just to keep our setup simple, but that is definitely something to look into if you're looking for some kind of a project management tool. For all of these, we have pre-user data and post-user data. Don't worry about these. These are just here for future compatibility or super advanced things that we use for testing, but just don't worry about these right now. And then finally, under system settings, we have enable automatic backups. I highly recommend this. If this is true, that means that every night, AWS will take a snapshot of your depot and log volumes, which will also contain a backup of your entire database. So that means that at least every night, even if the worst happened and your server was completely corrupted or destroyed, you would have those nightly backups to roll back to if you ever needed to. And I'll show you later on in this video about how you can adjust the frequency and the number of those stored snapshots if necessary. Last 2 things is environment. This name will just be appended to all of the names of the different resources that are created. So this makes it really nice and easy to search for those. So if I type something like ESP demo, you'll see later that that shows up on all of the different resources. And then at the end here, I'm going to put in my email address. This will be used by AWS's simple notification system to notify you if anything goes wrong with these checkpoints and backups and validation of your database. That's a very important thing to be notified about, so definitely recommend putting your email address in there. You will receive an email asking you to confirm that so that they can send you emails. Lastly, I'm going to acknowledge these two things, that it's going to be creating these resources and getting some capabilities, and I hit Create Stack. This will then bring us to our CloudFormation Stacks page where you can see Create in Progress. Now, if I hit refresh on these, you'll see that they're very quickly going to grow to all sorts of things as it's creating the IAM roles, the backup policies, our actual virtual private cloud with its various subnets and route tables. All of these things are getting created for us here. So you're just going to leave this for now and come back in maybe 15 minutes or so when this should be set up. That can vary, but we'll come back and check on this in a little bit. While that's installing, let's go and make sure that we have the P4V client installed on our machine so that we can actually connect to our server once it's up. So we're going to go here again to Products and Helix Core, which is where we just were. And under Helix Core Clients, we'll see the Helix Visual Client. This is the client we're going to download and install because this will include not only the visual clients, P4V and P4 Admin, it will also include things like P4 Merge and Diff and the command line client. So it's just the easiest way to get all of those in one step. So on here, we can scroll down to the bottom to where it says get the latest version of P4V and hit download here. And then we will choose what our operating system is. In my case, it's Windows, and you can choose the EXE or the MSI, doesn't matter. And I'll hit download. I've already installed this, but when you go through that installation step, one of the things it's going to ask you for is your server's port number. You can also leave that blank for now, and you'll just be prompted every time you run P4V. But if we want to wait so that we can put that in, we're going to wait for our CloudFormation to finish. Okay, it's been about 15 minutes, and our CloudFormation events has this final one called Create Complete. And if we look on the left side here, we'll see everything says Create Complete. Enhanced Studio Pack, this was our main one that spawned all of these child processes. And then we will go to our outputs. Under outputs, this is where we're going to get all of the important information about our server. So one of these that we should note is our P4 commit public IP. This is the public IP address attached to the Perforce master server. Some of these names may change in the future, but it's the one that's the public address for the Perforce server. So if we take this here and copy that, if we open up P4V, we'll be prompted for our server or our P4 port if we're doing that installation. And what we want here is to type SSL:, so that means we're going to use a secured connection. And then we need to put in that IP address that we just copied out of here, this IP address here. And then I will put another colon and 1666. 1666 is the default port for Perforce Helix Core. And then for user, the default super user is named Perforce, all lowercase. And I'm just going to hit OK. If this is your first time connecting to the server, you're going to get this little pop-up here to verify the authenticity of your server. So if you're sure that this is the right IP address and this is the right connection, you hit trust this fingerprint and connect. You won't get that prompt then in the future, but any new user connecting to your server will. And now here for our password is going to be our Helix Core instance ID, which is this one right here that I can just copy. Now, if I were to navigate away from this outputs page here, I can get that by going to EC2, which again, you can get to up here if it's not pinned at the top. If you click this little star, it will pin it to the top there. And if I go into EC2, now that I've run this, you will see that under instances, I now have two instances because I did Helix Core and I did Swarm, and I will see that two of those are running. So if I click on this, I can see them, And that ESP tag is attached to both of those, and I can see their instance IDs here. So if I ever did forget that password or lost that output, I can always log into my portal here, and then I can go get that instance ID again here by copying it. So going back to P4V, I'm going to paste that password in here, hit OK, and then I will be connected to my brand new Helix Core server. You can see that I'm connected to that server as the Perforce user. And if I want to do admin on this server, from the Tools menu up here, I can choose Administration. And this will open up a separate window of Helix Admin, also known as P4 Admin. And you can see that this opens up. It shows me what version of the server I'm running, my P4 root value, how many licenses I have. By default, there is a license that's free for 5 users and up to 20 total workspaces. The Perforce user takes up one of those. If you have less than that, it's totally free to use. And you'll see this also sets you by default to the highest security level, which is what we want. Over here in users and groups, is right now I have 2 users actually because I deployed Swarm along with it. So that has a user for the automation between those. If I did not install Swarm, then I would only have the Perforce super user. So then I would still have 4 slots left. And once you pay for licenses, then both of these will not take up a license. You can just request free extra licenses for those. So if I wanted to come here, I could make a new user, fill out this form with information about them, give them a password, assign them to groups, all of those things. I'm not going to worry about that for right now. We've got plenty of other videos about making users and managing permissions. Similarly, I can come into depots here, and this is where I could come and I could go File, New Depot, and make my cool project here. And then I would choose for this to be a stream depot. And then you'll see that shows up on this list. And then back in P4V, if I hit refresh, my new depot pops up here and shows up here. And this is a stream depot, which I would definitely recommend. Again, we've got lots of other videos about creating streams depots and how to set up your streams and things like that. Connecting to P4V that way is great for all of your daily use and most of your users, creating workspaces, submitting files, getting latest changes, all of that. But there are some things that we actually need to do by getting into the terminal itself. So to do that, we're going to click on the instance ID for our Helix Core instance here. And up at the top, we have this button that says Connect. The easiest way to do this is using the session manager. This is already set up that way. If I just hit Connect, this will open up a terminal right here in my web browser, so I don't have to worry about anything else. I don't even need my private key that I set up earlier. And you can see I'm just in my server now. And if I print my working directory, I can do that. And I have sudo access, so I can switch to the Perforce user. So sudo su Perforce. This is where you will do most of the things involving your Helix Core server. The one other one you might want is if you do sudo su just by itself, then you will be root. Now, it's a best practice not to do too much as root, but for things like increasing the sizes of our volumes, which we'll do later in this video, we will need to have this root access. The other way to connect to your server, which myself and most admins prefer, is to use SSH. So for this SSH client, we can get some instructions. Unfortunately, these instructions are not correct. There's a few things that we're going to need to change from this. So let me walk you through this. One of the things, as I mentioned before, that I like about using PowerShell instead of something like PuTTY is that these same commands will work on Linux, Mac, or Windows. And that is just using the built-in OpenSSH system for doing this. So if I start by typing SSH and then -I is going to specify what key I'm going to use. Mine is just right here in this C/ESP demo. And it was my new key without the .pem. That's just how mine happened to be. You can see this command has you connecting as root at, and then this DNS entry for the server. I could also connect directly to the IP address by putting that here instead of this DNS. The one big difference here is that we actually need to connect as the Rocky user. And then we just paste that DNS name at the end there. We're going to connect as Rocky because that's the one who's using this particular SSH key, not the root user. And I'm going to hit enter. The first time that you connect, kind of like with P4V, you're going to be prompted to trust this fingerprint. I'm going to say yes. When you connect through SSH as the Rocky user, you'll actually get this nice little splash screen that has some extra instructions like how to switch to the Perforce user if you forget, some things about starting, stopping, and restarting your server, as well as some links to documentation. All of that's here for your convenience. So this is generally the preferred way to connect to your server, but you are welcome to use the web terminal as well. And I'm just going to use that for the rest of this video just for simplicity. Next, we need to set up our server so that other people can connect to it and not just us. Because if you remember, when we were setting this up, we put in our public IP address as the one that will have permission to access the server and SSH into it and all of that. Because of that, though, it means that if another user on a different computer tried to connect to our server through P4V, they're going to get an error. They're not going to get any access to that. So what we need to do is adjust our security groups in AWS. So if I go back to EC2 here, and I go to my instances, and again, let me look at my Helix Core one, and under security here, we have a security group. And a security group is like a firewall that runs in the cloud. And I can look here at my inbound rules, and I can see that port 22, which is SSH, and port 1666, which is Helix Core, are both set to only allow traffic from my IP address. So what I'm going to do is I'm going to edit inbound rules, and I'm going to come here to the one for SSH. I want to actually leave that as restricted to just me. But this one up here for port 1666, if I have remote users, I want everyone to be able to do that. So I'm going to choose anywhere, IPv4, which is this 0000/0. And I'll just hit save rules. So now if someone else in another part of the world, as long as I give them my SSL : IP address : 1666, and they have a username and password, they can connect to my server. While we're here, just note that for Swarm, if you want your users to connect to that, it also has a security group. In this time, it's the rules for HTTP or HTTPS that we will need to modify from just my IP address to that open to anywhere. So that right there is enough for you to get a server up and running, but we're going to cover a few more things that can help you in maintaining this. So one of those is backups. So I mentioned before that AWS is going to be taking snapshots of a couple of our drives every night automatically. The way that we can find out about that is by going on the left side here to Elastic Block Store, EBS, and Lifecycle Manager. If I click on Lifecycle Manager, again, make sure I'm in the right region, I will see here that one has been created for me called Perforce Backup Policy, and it has that ESP demo that I put in there. If I click on this, bring this up here, or just go to the policy itself here, you'll see here that there's a schedule. It happens every 24 hours at midnight UTC time, which is basically London time, or at least very close to that most of the time. So if that gives you a sense of, oh, okay, so if I'm on the west coast of the US, for example, this might actually be 6 p.m. for me or something like that instead of midnight. So maybe I want to change that. Then we also see a maximum of 90 snapshots will be retained, and the oldest snapshot will be up to 3 months old. So what I can do is I can actually go up here to modify, and we can keep all this part up here at the defaults, but down in the schedule details, this is the part we might want to change. So we can go to modify here. I could change this to happen weekly, monthly, yearly. Daily is good. I would recommend that. But maybe I don't need 3 months worth. Maybe I just need 1 month worth. So I'll just keep 30, for example. Also, as I mentioned, if I'm on the West Coast in the US, this is actually a little bit early in the day for me. Maybe I actually want this to be at 8 a.m. UTC time. So that'll actually be closer to midnight for me. And then I can hit review policy, check on those changes that I made here, and I'll say modify policy. These snapshots then will be stored under Elastic Block Store under snapshots. I don't have any because I just created this, but around midnight West Coast time, that will get created and I will have my first snapshot in here. I'll actually have two because it's snapshotting the depot volume as well as the logs volume. Speaking of disks, if we go to volumes here, we can see all the different disks that were created. So we can see here that we have this one called HX logs, this one that's HX metadata, and this one called HX depots. So my depot volume, as I mentioned, is the one where we're actually storing our file data. Now you can see that these are 10 gigs, and 100 gigs respectively, but what if I start running out of space? And for this, once we're connected, I'm going to click in here and I'm going to go sudo su to become root. And the command I'm going to use is this df, which is disk free. And then I'm going to say -h because I want to see in human readable numbers. So it's actually giving me sizes in megabytes and gigabytes instead of just a long number of bytes. So I can see right now that I have basically 100 gigs free. But let's say I was running out of space on this HX depot's volume. I would see that here of, oh, my available space is now really small. I don't have much left. So I would go back to my volumes here. I would find that volume, and I can't see how much free space I have from here. I can only check that from inside my instance for security reasons. But I'm going to look at this and say, okay, that's 100 gigs. I need to make it bigger. With it selected, I'm just going to go up to Actions, and then modify volume, and then I can just increase it. So let's say I needed to go up to 200 gigabytes, or I needed to modify my IOPS if I noticed my throughput was a bottleneck or something like that. But in this case, I can just say 200 there. Just a quick note, I can also change the drive type. So if that's something you look into and you decide, actually, I'm okay with saving some money using a hard drive, or I want even more performance, I can go to an IO1 or a 2. I think it's rare that you'll get into situations where you'll really need those, but those options are there for you. And I can just hit modify, and it will warn me about this, that I also need to extend the file system. So we'll do that right now. I'm going to hit modify, and if I look at the status of my disk and I hit refresh up here, you can see that it's in use, optimizing, and that process will go, but we actually already have that space. If we just do df-h again, we'll see there's no more space yet on that. What we have to do is actually expand the file system. So we're going to do that with the command xfs, that's the type of file system, _grow fs, grow file system. And then we need to specify which mount point. So in this case, it's this /hx depots. So I just go /hx depots, hit enter, and it says at the bottom here, data blocks changed from this number to this bigger number. And now if I hit up twice and df-h, I can see now this is a 200 gig volume instead of a 100 gig volume. So really easy. I can do that similarly with my HX logs and HX metadata just by coming in here and increasing the size or changing the disk type. Another thing you might want to monitor about your instance is its performance. So again, if I look at my Helix Core instance here, I'll actually click to go into it. And if I look down at monitoring here at the bottom and I check on this, I can actually see things like my CPU utilization. And I can see, okay, I peaked up there to 22.4% of my total CPU. And I can change the timescale of this so I can look at it. But if I'm noticing, you know what, I'm pretty constantly maxing out my CPU, I should increase the type of my instance. Or if I realize, oh, you know what, I'm barely utilizing this, let me decrease the size of it so I can save a little bit of money. One thing we can't see here is our memory usage because AWS doesn't have visibility into the memory inside of your instance, again, for security reasons. So that's something you could come in here and check yourself in the terminal if you think memory might be an issue. But I'm not going to get too into the details about that. You could also reach out to support once you have a license, and they might help you diagnose those things as well. But let's say we see that our CPU utilization is high, and so we need to increase the size of this instance. What we do then is we have to go to our instance state, and we will have to stop our instance. So this is important to note that you need all of your users to be disconnected or not working. So this is something good to do overnight or on the weekend when people are not connecting. I'm going to hit stop instance, stop. I did this from the instance page here. I could have also done that from the list of instances here by selecting it and again going up to actions, or I'm sorry, instance state and stop. You can see I have this filter by running instances. Let me just turn off that filter so I can see this one that's stopping as well. And I do have to wait until it is all the way stopped. Sometimes that can take a little bit of time. Okay, that took a couple minutes, but now it is stopped. And now if I select it under actions, I can go to instance settings and I can change my instance type. Now note this will be grayed out if my instance has not stopped yet. So if you see that grayed out, that's why. And then I can come in here to my instance types and I can just scroll through this massive list and again reference that Vantage site to see what kind of instance you want. In this case, I'm on a T3 micro right now, so maybe I want to increase this to something like maybe a T3 medium, a little bit of a step up from that T3 micro, hit apply, and this will happen pretty much instantaneously because it's stopped. And then if again, I select it and I go to instance state and now I start my instance, it'll take a little bit to start back up and be accessible, but now you can see I'm running a T3 medium that's going to have more CPU cores and more memory. So really easy to shift that later on to adjust it to be exactly the right size for what you need. I hope this video has been helpful and you're able to quickly get yourself set up with a Helix Core server that you can grow to be as large as you need it to be and is production ready right out of the box, or by choosing something really small like a T3 micro and keeping your volume small and not doing too many snapshots, you can actually keep it quite cheap so it can be your own personal development server with that free for under 5 users license. So I hope this has been helpful and I will see you in the next video.